Hi, it's me, Dr. Prasad Puthiyillam. Continue my coaching classes, entrance coaching classes for CET, JEE, NEET through my YouTube channel, My Intuition. This is class number 1 of solid state. Body-centered cubic lattices has a coordination number of 6, 8, 10, 12. So a body-centered cubic lattice can be represented like this with the atom at the center that we call as body-centered cube, a cube with the atom at exact center. It has got 4 atoms at the top here and 4 atoms at the bottom towards the corner of that cube. Therefore, we can say that there are 8 atoms surrounding that. So in a particle with a BCC lattice, it has got 8 atoms as the nearest particle. Therefore, correct answer is 8. Attractive forces are stronger than separation forces in pure substance when its physical state is solid, gas, liquid, colloidal. Okay, we know gas molecules are very free. Liquid molecules are somewhat free. They have freedom of movement. Colloidal particles, it may be liquid case or gaseous case also. Therefore, solids have particles that cannot be moved by themselves. Hence, the attractive forces should be greater than repulsive forces. Therefore, correct answer is option number 1, solid. The coordination number of cations occupying tetrahedral void in a crystal is option 6, 8, 12, 4. So a tetrahedral shape, it is represented here, and the tetrahedral shape occupying the void, it is created with 4 atoms. Okay, so these 4 atoms, when they arranged like this, it forms the tetrahedral void, 4 atoms or particles. Therefore, we can say that a void surrounded by 4 atoms is called tetrahedral void, and 4 is the correct answer. Whereas the octahedral void, okay, so octahedral void, it is represented there. The octahedral void, it is formed with 6 atoms. Don't confuse octa with 8. So the octahedral void is formed with 6 atoms. So say 4 in this plane, 1 at the top, 1 at the bottom. Therefore, we can say that octahedral void is surrounded by 6 atoms. Three-dimensional array of points in space is called, that is by definition itself. Options are crystal lattice, unit cell, crystal structure, lattice point. So by definition, crystal lattice are the three-dimensional array of points in space. AB close packed structures represents simple cube, body-centered cube, or body-centered cubic close packing, face-centered cubic close packing, HCP, hexagonal close packing. Okay, so we'll see the AB type. So let me arrange the A type. So this represents A type arrangement of atoms or particles. Okay, it should be spherical in shape. So imagine that these rings represents a sphere, represents spheres. Okay, the B type, if I cover the void, okay, of that first layer, then I can say it is a B type layer. Okay, so again AB. So again the third layer, it is the same as the first layer, that is A type layer. The fourth layer, that is B type. Fifth layer, again it is A type, and the sixth layer, it is B type. So here we can see, after arranging these atoms like this in a three-dimensional space, if you imagine, we can see that it forms a hexagonal shape. Therefore, AB type arrangement of atoms in a closed packed structure, it forms hexagonal cubic closed packed structure. Therefore, HCP, option number 4, is the correct answer. Amorphous solids possess sharp melting point, possess different physical properties, are supercooled liquids, possesses crystal symmetry. Okay, amorphous solids, they are not having sharp melting point. They have almost same physical property. Okay, and they are supercooled liquids. They are not crystals itself. Therefore, amorphous solids are formed by the solidification of liquids without crystallization, or you can say it is supercooled. From liquid state, it is converted to solid state in a fast rate without allowing the atoms or molecules or the particles to crystallize, to go and occupy the crystal lattice points. Okay, therefore we can say that they are supercooled liquids. Crystalline solids are, okay, this is the same question. Okay, crystalline solids are supercooled liquids, always isotropic, maybe anisotropic, not having sharp melting point. Okay, so previous question was with amorphous. Now crystalline solids, they are not supercooled liquid, always isotropic. No, crystalline solids, they are always not isotropic, maybe anisotropic. It's the correct answer. Not having sharp melting point. Crystalline solids are having sharp melting point because the crystalline arrangement such that it melts at a particular temperature. There is no variation, like just like polymers. Polymers are example for amorphous solids. They will melt at a range of temperature, whereas the crystalline solids, it has got a sharp melting point. Okay, so that anisotropy, that is the property in the same crystalline structure because of the different in size of different atoms or the properties. Okay, even though they are crystalline arrangement, well-defined arrangement, at different planes, say AB plane or CD plane, the particles present are different. Therefore, properties like refractive index, all those properties are different at different planes. We call it as anisotropy. That particular property is known as anisotropy. Okay, therefore it may be anisotropic. Okay, it is not sure that all crystalline solids are anisotropic. Crystalline solids have anisotropic behavior also. Some of the crystalline solids have anisotropic behavior. Crystalline sodium chloride is a bad conductor of electricity because, okay, sodium chloride, that is our table salt. Okay, table salt, don't try that. It is mentioned that it is a bad conductor of electricity. If it contains moisture, it will conduct electricity. You feel the shock. Okay, the options are: it contains only molecules, it does not possess ions, the ions present in it are not free to move, it does not contain free molecules. Okay, so if it is a crystalline solid without presence of moisture, pure crystalline solid in the sense there is no moisture present. If moisture is there, we can consider it as solution. Okay, so a crystalline sodium chloride in which the ions Na plus and Cl minus, NaCl, sodium chloride NaCl, we split it as Na plus and Cl minus if it is solution state or molten state. Okay, those ions, if it is there, then it will conduct electricity. If the ions are not free to move, okay, the ions present in it are not free to move, then it is a bad conductor of electricity. Electricity, the movement of electrons or current, the charge carrier cannot, that it cannot act as a charge carrier. It cannot carry the charge. Okay. Unit cell of sodium chloride crystal is body-centered cubic, simple cubic, face-centered cubic, hexagonal close packed. Sodium chloride just like a two sodium crystal and chlorine system combined. So you can say this is the representation of a sodium chloride crystal. It is a face-centered cubic. You can see some atoms are at the face of that cube structure also. Therefore, we can say it is a face-centered cubic. Example for face-centered cubic. Okay, all the supporting classes for solid state chemistry are available in my YouTube channel. All the possible objective type questions, that is the entrance exam questions, will be discussed in detail in my YouTube channel. Please do subscribe my YouTube channel. If you have any queries, please put it on the comment box or to my WhatsApp number, which is displayed there. So thank you very much. Do subscribe my YouTube channel and support me. Once again, thank you very much. Have a nice day.